So we're going to go over the squeeze theorem and discuss how to apply it to find a limit at a point of a specific function. Squeeze theorem generally comes into play when you have three different functions and they're all less than or equal to each other, and like what you see here, and when their x value is near our limit a value, except possibly at a. So when you see when you take the limit of both this f function here and this h function here with the same a value, if they're equal to each other, then you can assume that the limit of the g function with the a value is going to be the same. So we go over a quick example of this. So what we have here, we have two functions, 1 plus 4x squared, and then another function at 3 minus 2x to the cube. So we need to find, with our a value at -1, the limit of our function g of x. So looking at this, if we let this be our f of x value, so f of x is equal to 1 plus 4x squared, and we let this function be our h of x. We could take the limits of both of these functions with this -1a value and see if they're equal to each other. So let's go ahead and do the limit for function x. So limit for function x, -1. So we have 1 plus 4 -1 squared, and we end up getting an answer of 5. So if we do the same thing for our h function, so 3 minus 2 times a -1, and we also get 5. So since our f of x function and our h of x function share the same limit, then we can assume, or we know, according to the theorem, that the limit of our g of x function is also going to be equal to 5. We'll go over one more quick example. So if 2x is less than or equal to g of x, for all x, evaluate the limit for g of x, and our a value will be 1. So once again, same thing. We just take a look here. We can assume, or if we use this 2x function for our f of x, and then for our h of x, we can use this function. We can find the limit for both of these functions with our a value at 1 and see if they're equal to each other. So the limit for f of x is going to be equal to 2 times 1. Gives us an answer of 2. And then our limit for h of x So that also gives us a value of 2. So once again, the theorem checks out. They're equal to each other. So we know that the limit for g of x is also equal to 2.